Hi everybody, and welcome to tonight's video where we're going to be talking about a few different theorems that we're going to see in this section of our book. And we're just going to do a simple demonstration of each and kind of explain using some diagrams what each one means. So the first one that we're going to talk about is called the triangle or exterior angle inequality theorem. So if we're looking at the triangle that we have here, we have four angles that are labeled, angle 1, 2, 3, and 4. And which one is the exterior angle? So if you're looking at the picture, exterior angle is the angle that's on the outside or the exterior of the triangle. So in this case, angle 1 is what we would call the exterior angle of the triangle. Right? And we get an exterior angle by extending one of the sides of the triangle and then measuring that angle on the outside. Angles 2, 3, and 4 are the interior angles, right? Angle 2, angle 3, and angle 4 are all three inside the triangle. So angle 1 is the exterior angle, 2, 3, and 4 are the interior, and we'll remember from a previous chapter that the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3, right? That's called the exterior angle theorem. And we could solve this, or prove this, I should say, by using what we know about the sum of the interior angles, that angle, the measure of angle 2, measure of angle 3, and the measure of angle 4, all add up to 180. And then what we know about linear pairs, that the measure of angle 1 plus the measure of angle 4 equals 180. And then since both of those equations equal 180, we could set them equal to each other, subtract the measure of angle 4 from both sides, and you'd end up with this. Measure of angle 1 equals measure of angle 2 plus measure of angle 3. Great. Okay, so that's a little refresher. The exterior angle inequality theorem uses the definition of inequalities that we talked about in class today. And what that says is, if the measure of angle 1 equals the sum of these two angles, the measure of angle 2 plus the measure of angle 3. So if that's the case, which we said happens when you have an exterior angle and two remote interior, if that's the case, then the measure of angle 1 has to be greater than the measure of angle 2, and the measure of angle 1 has to be greater than the measure of angle 3. So this exterior angle is greater than each one of these individually, right? And that makes sense because the two of them together add up to be this angle. And so if you just take one part, then the smaller part, measure of angle 2, then you know that it's got to be less than the measure of angle 1 because it's missing the other piece that together they add up to that. Okay, so that's what the exterior angle inequality theorem says. It says that that exterior angle is going to be greater than the measure of each individual remote interior. Now, it may or may not be the case that angle 1 is greater than angle 4. You'd have to determine that by what kind of angle you have here. If angle 4 itself was obtuse, then our measure of angle 1 here would be less than angle 4. So there's nothing really that says with this exterior angle theorem anything with the relationship with its linear pair, just with the relationship of the remote interior angles. So this is your conclusion that you would get. I know it gets a little confusing looking here, sloppy with the measure and the angle symbol and the inequality there. So just remember this is measure of angle 1. This isn't m is less than 1, right? It's the measure of angle 1 is greater than the measure of angle 2 in this case, and measure of angle 1 is greater than measure of angle 3 in this case. But in general, the remote interior angle, whatever this name is, if it's a number here, if you're using the 3 letters to identify the angle, that exterior angle is greater than each individual remote interior. Okay? So that's the exterior angle inequality theorem. Another theorem that we're going to talk about in this section is called the angle side relationships theorem. And this requires a comparison of two angles within the triangle. So this says if one angle of a triangle is greater than, right? So if the measure of one angle is greater than another angle, so in this picture that we have here, how would I say this first statement? One angle of a triangle is greater than another angle. So which angle here is greater than another one? So I would say in this case that angle B, and we'll say measure of angle B, is greater than the measure of angle A. How do I know that? We'll look at it. Angle B here is wider than angle A. Okay, so this is an obtuse angle I can see right here. Here's angle A, clearly an acute angle. So the measure of angle B is greater than the measure of angle A. So that's the first half of this angle-side relationship. So if one angle of a triangle is greater than another angle, the conclusion to this is then the opposite side of the greater angle, or the larger angle, you could say, is greater than the opposite side of the smaller angle. Okay, so this is that's why we call it the angle-side relationships theorem. So depending on the angles, that's going to tell you something about the opposite sides and their relationships. So in this case, the measure of angle B is greater than the measure of angle A. So that's the first part, the hypothesis to this theorem. The conclusion then says, if that's the case, then the opposite side of the greater angle, which in this case is AC. So if measure of angle B is greater than the measure of angle A, then we could say AC, and we don't need a lowercase m when we talk about measures of segments. We just use the two letters without the bar over the top. So then AC is greater than, okay, that's the opposite side of B. So what's the opposite side of angle A? That would be BC, right? So AC, the side AC, is greater than BC. And if we look at the picture of this triangle here, that's also pretty obvious to see. So clearly, measure of angle B here is greater than measure of angle A. If I look at that, what that tells me, according to this theorem, is that the side AC is bigger than the side BC. If I look at the picture again, that's pretty clear. AC is much longer than BC, okay? And so basically the way to think about this is the wider you have to open an angle, this is the larger the opposite side is going to be. So it's like, I think we've used like the example of trying to get something through a door. So if you're trying to trying to move a large object through a door, you have to open it wider. So that's why the wider the angle, the longer the opposite side. Same thing here, the smaller the angle, the shorter the opposite side. So that's the angle-side relationship. So if you have two angles where one's bigger than the other, then you know that their opposite sides are going to follow the same inequality. Okay? And then following off of that, we have the side angle relationships theorem. And this is just kind of the converse of the previous theorem. And what that says is if one side of a triangle is larger or greater than another side, so if one side of a triangle is greater than another side, so in this case we'll say PR is greater than PQ, right? And that's pretty clear from the picture. Here's PR, here's PQ. Obviously PR is longer. So if the sides are longer, or one's greater than the other, then following the same logic as we used before, then the opposite angle of the larger side is greater than the opposite angle of the smaller side. So it's just the kind of the converse of what we just said. So if PR is greater than PQ, which we can clearly see from the picture, then the opposite angle of PR. So here's PR. The angle opposite that is angle Q. And so that's going to be greater than the angle that's opposite of PQ. So here's PQ. The angle opposite it is angle R. So we would know that the measure of angle Q is greater than the measure of angle R by using these side angle relationships. Okay? And so we're going to do some worksheets with this in class tomorrow. We're going to do some examples where we're going to be given a picture and we're going to be asked, we'll be given a piece of information and then we'll have to fill in. So it might tell you which sides are longer and then you'll have to say which angle is bigger than which. And that would be using side relationships. Or it might tell you which angles are bigger and then you'll have to determine which sides are bigger. And it's not always going to be as easy or plain to see as this. It might be a triangle where it looks almost like it's equilateral, so you'll just have to tell using the given information. And then finally, we'll use this first theorem where, again, it'll kind of complicate things. It'll put multiple triangles in the same picture, and you'll have to determine which angle is actually an exterior of which other triangle. And then you'll have to identify which angles are bigger and put them in order, something like that. So make sure you got all these notes written, understand the different examples. If you have any questions, bring those with to class tomorrow, and we'll do some practice with these then. Thanks and have a great night.